we're here in Iceland together with an airplane from NASA to experiment using a radar that has been mounted on the side of this airplane and to see how well we can measure the velocities of the surface of the glaciers in Iceland. We're here in Iceland in particular because a lot of it has already been studied in Iceland. We know the shape of the glaciers, we know a little bit about the history of the glaciers, all this because of the work that's already been done by our colleagues here at the university and other institutions in Iceland. Our hope is to be able to use these measurements of the surface velocities to actually say something about the basic mechanics of how these glaciers work. We're trying to understand how the deformation of the ice happens, how much is happening within the ice, and how much is happening at the base of the ice, and how that varies over the different seasons, over the summer and the winter. Brent is here, Brent Minshew is working on actually making these measurements and interpreting them, and he can tell you more about what we have found so far using observations from 2012.
So what we see from a number of different INSAR observations and our estimates of the velocity fields using those INSAR observations is that the speed of the glacier moving along the bedrock itself is actually reducing as the melt season continues, starting from early in the melt season and about 2 weeks later. And we think that that's attributable to changes in the drainage system, the water drainage system at the bed of the glacier itself. And that's a particularly interesting and challenging problem, and this data really gives us great insights into that.
So one of the exciting things is that the technologies that are being developed here that we're exploiting with these airplanes, this airplane, is usable in other places. So we're using Iceland as a natural laboratory both to develop the technology and to do some interesting glaciology to understand what's going on here. But all of this is in fact portable to understanding the cryospheric behavior more generally in Greenland and Antarctica, and eventually to help improve our understanding of the fate of the cryosphere, sea level rise, and other problems associated with global change, climate change.